Today we're going to look at the angle-angle postulate. We've already seen that to determine if two triangles are similar, two things must be checked off. First, corresponding angles must be congruent, and then second, all corresponding side lengths must be proportional. And if the two triangles are similar, then we can use that to determine missing information. But you'll probably agree with me that checking all of that to determine similarity is a lot to do. Well, you're in luck. Today starts the shortcuts in determining similarity. The first one we're going to discuss is the angle-angle postulate. So, what does this postulate say? The angle-angle postulate says, if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Now, some examples will be straightforward, and some examples are going to make you work to determine similarity. So let's look at some examples. We've seen examples before where two triangles are drawn separately of each other. So let's start with this example. Question is triangle WHS similar to triangle GEO? If so, we got to explain. So let's see what we have. Right now I see that angle H is congruent to angle E in the other triangle, which is good. Then I've got 65 and over here I have 35, so I don't see anything else. What I do know is how to find a missing angle of a triangle. How do we do that? You're right. Let's take the two angles that we have, 80 and 65. Let's add those together. Take that quantity and subtract it from 180. And let's see what we get. All right, so 80 plus 65 is 145. And that subtracted from 180 is 35. All right, so let's erase the question because it's no longer a question. We know that this is 35 degrees. Perfect. What do you see? I see now that angle 35, which is angle S, is also over here for angle O. So, do we have enough information to determine if the two triangles are similar? Yes, we do. Why or how? By the angle-angle postulate. Remember the angle-angle postulate says, if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Perfect. Let's look at another example. We have also seen stuff like this. We've seen when triangles are overlapping with each other. So let's answer this question. Is triangle BAC similar to triangle DAE? So what do we do when we have overlapping triangles? My suggestion to you guys is redraw the triangles separately. So let's draw triangle BAC. And then let's draw the big triangle, which is DAE. So after you redraw the triangle separately, you need now to mark what was given to begin with. So I look back at the original problem and I see for triangle BAC that angle C was 27 degrees. And also that angle E is 27 degrees. From there, after you mark what's given, you need to mark what was shared. There was something that was shared because the two triangles were overlapping to begin with. So what was shared? Can you look at the original example, the original drawing, and determine what was being shared or what is being shared by both? If you said angle A, you are correct. Angle A is being used for both triangles, so we need to mark that they are congruent with each other. Now, we don't know to what exact degree angle A is, but we do know that they are congruent because they were both shared. Do we have enough information? Can we determine that triangle BAC and DAE are similar? Yes, we can. Why can we? We have two angles in one triangle congruent to two angles in another triangle. So it's automatic that it's similarity because of the angle-angle postulate. Perfect. Let's go to another. So we've seen triangles drawn separately, we've seen triangles that are overlapping with each other, and we have seen something like this, where triangles are connected. Is triangle QRS similar to triangle TRU? If so, explain. All right, so what do we got so far? Looking at the main drawing, I have that angle Q is congruent to angle T in the other triangle. So we're halfway there, because all we have to find is two angles. And then I have no other information that it appears. Can you find another angle that is congruent based off of prior geometry knowledge? You're right. Vertical angles. Where are those vertical angles? Vertical angles are sitting right here. R and R. Is triangle QRS similar to triangle TRU? You got it. Why? The angle-angle postulate. Remember, the angle-angle postulate says all you have to have is two angles in one triangle congruent to two angles in the other triangle. Then the triangles are similar. Let's go with one more example. Is triangle ABC similar to triangle DEF? Explain. I'm going to erase this up here from the previous example. Start with a clean slate. All right, so here we go. What do we got? Okay, we got two triangles that are drawn separately, very similar to the first example. So what do we need? We've got angle A is congruent to angle D. Okay, so we have an angle already. And then we have nothing else that is shown. But we've already talked about how to find the missing angle of a triangle. So let's go find out what the measure of angle B actually is. What is the measure of angle B? All right, let's take 30 and 50 and add them together. It's the two angles that we do know. And subtract that from 180. 30 plus 50, 80. Subtracted from 180, and that is 100. Okay, so it's no more question mark. We know this information, and we found out that it is 100 degrees. Perfect. 100. I don't see 100 over here. There's a 110, but some of you may be saying it could be here. All right, so let's answer that question. Let's figure out what the measure of angle F actually is. Let's take the two angles that we've got, 110 and 30, add those together, and subtract from 180. 110 plus 30 is 140. Subtracted from 180, not hot enough. So angle F we found out was 40. So looking back at the main picture, is triangle ABC similar to triangle DEF? No. Why is it not? Well, if we're talking about the angle-angle postulate today, all we could find is one angle is congruent to another angle. And in order for two triangles to be similar with this postulate, we have to have two angles in one triangle congruent to two angles of another. So I hope everything went well, and I will see y'all in class.